we go. 4.1. Graph quadratic functions in standard form. Okay. We are going to use a lot of our knowledge about graphing, yes, absolute values, and apply it to graphing parabolas, okay? Everything is going to relate. We're going to do lots of different graphs. This is just the beginning of one type of graph we're going to do this year. And when we get done with all of them, we're then going to do a project with all of them. Yeah. You've got to know how to graph. To move on from this math into any math that you are taking next year, you have to know how to graph. Period. Okay? So graphing a quadratic function is a function that can be written in standard form. The standard form is y equals ax squared plus bx plus c, where my a cannot equal 0. You have to have an x squared as a leading thing. Okay? So your a can't be a 0 or else you don't have a quadratic function. Okay? The graph of a quadratic function is a parabola. If you notice down here, this is the parent function. Every function that we talk about is going to have a parent function, just like our absolute value parent function was f of x equals the absolute value of x. Okay? And it had a vertex at 0, 0, and then it was like 1, 1, negative 1, 1. Okay? And we compared it to that. Same thing is going to happen with our quadratic function. Our quadratic function, parent function is f of x equals x squared. Okay, f of x equals x squared. The parabola has a vertex, okay? The vertex is considered a minimum or a maximum in this case, okay? In this case, on a standard function or on the parent function, I have a minimum because it's the low point, okay? If my graph is facing up, I have a minimum. If my graph faces down, I have a maximum. Use some common sense, you can do it, okay? There is an axis of symmetry, so once again, if I plug in a point and get a number out on the right side of my graph, I can reflect that over the axis of symmetry and just graph my parabola from there, okay? So it's not going to take a ton of plug and chug, but it takes a little. Parabolas are curved, they're nice and smooth, okay? They're not pointy like an absolute value. So if you graph it with a point like an absolute value, your graph is incorrect. I will mark it wrong. You will get it wrong on the test, quiz, homework, whatever, okay? You must curve it. They're curvy. Parabolas are curvy people. Okay. Okay. So we are going to actually graph several of these today. If I can.
I can make it balance.
So that we can graph. And I think my board is off a little bit, so I'm going to have to recalibrate it later. Maybe I just struggle sometimes. Okay. So I'm going to graph the function 2x squared, and I'm going to compare it to the parent function of y equals x squared. So my parent function should start at 0, 0, and it should be at 1, 1, and negative 1, 1, and I have a parabola that goes that way. Now, if you plugged in a 2, what would you get out for the parent function? What is 2 squared?
4.
Okay, and if I plug in a negative 2, I get a... Okay, so it's growing exponentially by a power of 2. Now, if I'm graphing this, let's use some common sense. If I'm graphing y equals 2x squared, what do you think that 2 is going to do in front of my parent function?
Make it bigger.
What do you mean by that?
Wide.
Okay, so on absolute value, if the absolute value of A was greater than 1, your graph, did it stretch or did it shrink?
Stretch.
Okay, and if it had a fraction in front of it, did it stretch or shrink? Okay, so the same concept happens here. So what's going to happen with that 2 being in front? It's going to stretch. So what I'm going to do, my parabola, my vertex is still 0, 0 because nothing has been added or anything to this graph. So it's 0, 0, okay? If I plug a 1 in, I have 2 times 1 squared. What is 1 squared?
1.
1 times 2 is?
Yeah.
So I get 1, 2 is my point. So here's 1, here's 2, okay? This, I reflect it over the axis of symmetry. this is this parabola. You're going to have to be able to graph them on the same graph, and you're going to have to be able to explain into words that it was stretched by a unit of 2. Okay? Nothing new there yet, yes? Okay, we can handle that. If you take a look at graphing this is where some fun stuff happens. What does this tell me right here?
It's going to
Face downwards.
I heard lots of random stuff. It's gonna what?
Face down.
It's gonna shrink. What's the negative tell me?
It's going to be downward.
It's gonna go downwards. It's gonna flip down, okay? It's gonna flip down. It's going to shrink by a half a unit. What does that 3 tell me?
The vertex is going to be at 3, 0.
Good, good. So my parent function, once again over here, is still 0, 0, 1, 1, 1, 1. Here's my parabola, okay? My new graph, the vertex is now at 0, 3, right? Okay, so it's shifted up 3 units. I also know that it should face down when I plug in a point. Okay, I'm going to plug in 1, make it easy on myself. Y equals -½ times 1 squared plus 3. What's 1 squared?
1.
What's 1 times -½
-1/2.
-½. So I get y equals -½ plus 3. What's -½ plus 3? 2.5. So my solution is 1, 2.5. When I plug 1 in, I get 2.5 out. Here's 1, here's 2.5. I have to do what to that point?
Curve it.
Deflect it. And then, yes, I am making a curved parabola. Okay? There's some rough sketches of some parabolas. Does that make sense so far? Okay, can you handle doing that? It's not that hard yet. Okay, then we get to this. Okay? Properties of the graph of y equals ax squared plus bx plus c. Graphing any quadratic function, you can use the following properties to graph it when it is in this form. What is this form called? What is y equals ax squared plus bx plus c?
Standard.
Standard. The reason you need to know that, listen, you need to know that this is standard form. The reason is this. We're going to learn vertex form as well. There's more than one way this can appear. Just like a line, you have linear form, right? And then you have point slope form. Okay? Yes. Yes, but we're going to talk about how you do that. So basically, if it is not in standard form, it's going to be in something called vertex form. If they want you to change it from vertex form to standard form, you have to do something called foiling. If you want to change it from standard form to vertex form, you have to create 2 sets of parentheses and factor. This chapter, you have to be good at factoring. We will spend several days on factoring. If you cannot factor, you are going to struggle from here on out. And that means factoring with a leading coefficient of 1 and factoring with coefficients that are greater than or less than 1.
Oh my goodness.
Yes. You must factor. Okay? So when it's in standard form, it's because I've already FOILed it all the way out. If it is in standard form, here's what you need to know. If you want to find the vertex, which we do because we want to actually graph this, you have to use this equation that says x equals the opposite of b over 2a. Doesn't matter if it's facing up or facing down, you're using x equals the opposite of b over 2a. Where is the b in my equation?
The middle.
In the middle, it's in front of my x. So I'm taking the opposite of whatever that is. So if it's -8, I'm plugging in a +8. If it's +8, I'm plugging in a -8. The a is always in front of my x squared. Okay? So here's what happens. I find the vertex first by doing the opposite of b over 2a to find x. When you find x, what do you have to do with that? Plug it back in to find y so that I can get a point. We're going to do it in a minute. This is applying to standard form. If you have something in standard form and you want to graph it, because we haven't done a hard one yet, you have to do it this way. You have to find the vertex first. So far, every vertex we've used has been 0, 0, or like 0, 3. Okay, so we haven't had to apply this method yet. But if the vertex, if those numbers are different, I have to apply this and I have to find the opposite of b over 2a. Plug that answer back into the original equation to find what y is, so that I have a vertex, an x and a y. Okay? What that means is this. Okay? You have a graph that looks like this. 2x squared minus 8x plus 6. In order to graph this, I first have to find a vertex.
X equals 8 over 2 times 2.
Yeah, so I'm going to do the opposite of b over 2a, right?
Yes.
Okay.
So only the b is negative?
Yes. It's easier to think of it that way. Does that make sense? Okay, so I'm going to say x equals the opposite of b over 2a. Okay, what is my b?
8.
In this case, it's negative 8, so that means I'm going to say 8 over 2, and my a is 2. What is 8 over 4?
2.
So my x is, what do I have to do with that to
Plug it
find?
in.
Plug it in. So I say y equals 2 times 2 squared minus 8 times 2 plus 6. What is 2 squared is 4, 4 times 2 is, and then negative 8 times 2 is
Negative 16.
plus 6. So what is 8 minus 16 plus 6?
Negative 2.
So your vertex is 2, negative 2. So I come over to 2, negative 2, I put my vertex. Oops, that's not negative 2. Okay, so I come over to 2, negative 2, and put my vertex. Now, is this graph facing up or down? Up. There's not a negative in front of that 2x squared. So it's facing up. What number do you want to plug in? I say,
1.
0, 0.
so y equals, you could plug 0 in, but I'm going to say 2 times 1 squared minus 8 times 1 plus 6. So I get y equals 2 minus 8 plus 6. So you get y equals what? 0. So your point is 1, 0. Here's 1, 0. What do I have to do with that point?
Reflected it.
Over here,
Dang it.
parabola. Okay? That's one example. I've got 3 more.
Oh no. No, 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 no.
Oh, yes.
No.
Okay, well, 2 more. We kind of touched base on this. You always have a maximum and a minimum, okay? A maximum and a minimum in parabolas, okay? Your maximum is always the peak if my parabola is facing down. My minimum is always the valley if it's facing up, okay? You know, a valley is low. Okay. From there, I have this, okay? I can actually classify this without doing any math, and then I have to do a little math to figure out what the exact point is. It says, tell whether the function y equals 3x squared minus 18x plus 20 has a minimum or a maximum value. Then find the minimum or the maximum. Looking at that graph, does it have a minimum or a maximum? Why? Because it's positive, so I'm positive it has a minimum. Okay, so it has a minimum. You don't even have to do work on that. And you answered part of it. Now, how do you find the minimum?
That's a good
No.
question.
Don't need to graph it. What is the minimum on the graph?
The vertex.
The vertex. Can I find the vertex
Yes.
somehow? How?
X equals negative b over 2a.
Yes. So I'm going to say x equals negative b over 2a because I need to find the vertex. What is my b?
18.
And my a is?
3.
So what is 18 over 6?
3.
Good. Now what do I have to do with that?
Plug it in.
So 3 times 3 squared minus 18 times 3 plus 20. 3 squared is 9. 9 times 3 is?
27.
What is 18 times 3? Negative
Negative
Is it 64?
I don't know.
It's 54, I think, isn't it?
Yeah.
Wait. Yes.
54.
It is.
Plus 20. Okay, what is 20? What's negative 54 plus 47?
27. Negative 27.
It's what, negative?
27.
Negative 7. Isn't it just negative 7?
Wait, what?
Yeah.
I was trying to figure out what everyone else was saying. I was confused. I was like,
So your minimum point is 3, negative 7. And this is your answer. Okay?
That's easy.
That should be easy, yeah? Okay. Last thing, let's talk about how we apply this to the real world. Okay, real world, this really does happen. Here's where we use parabolas in real world. It happens a lot. Use parabolas, actually, if you watch Sunday football or Monday night football or Thursday night football now, they actually do show equations of the pass rate from the quarterback to the receiver, and those are parabolas. They show the projection from the kicker's foot over the, yeah.
I see the like the little line that they do, but I didn't know that.
Those are parabolas.
Oh,
Okay,
that's awesome.
so in sports, that happens a lot. It also happens in business. Companies will a lot of times adjust things through mathematics to see where they can get the highest profit. Like, if we cut back on this cost, how many do we have to sell to get the highest profit or whatever like that. So there are a lot of mathematical things that go behind that, and parabolas are part of it. We want that highest rating, okay? When you have students' grades, when you have like a bell curve, right? It's like a parabola almost, same type of shape going on, okay? Things happen there. So this one is talking about a go-kart company. And they have a go-kart track. It has about 380 racers per week, and they charge each racer $35 to race. They want to know, the owners estimate that there will be 20 more racers per week for every dollar reduction in the price per racer. Okay? How can the owner of the go-kart track maximize the weekly revenue? If I'm maximizing, what does my graph look like? Down, because I'm finding the maximum value. Okay? So my equation should come out in standard form to have a negative with it. Okay? I'm trying to find the overall revenue. That's what I'm trying to find. My revenue right now is $35, okay? But that is $35 minus X, because I'm going to subtract money from it, but I don't know how much money I want to subtract yet, right? That's what we're trying to figure out. And then I multiply that by, currently we have 380 racers, yes?
Yes.
But we think we are going to get 20 more per dollar that we take away from there, correct? Yes?
Yes.
So what do you think we need to do to the rest of this equation? If I have 35 minus X, okay, as one representation, that represents how much I pay right now minus what I'm going to pay, okay? And I have 380, but we think we will get 20 what? More. So what does that mean?
20.
Add 20 times what though?
1.
20 times what? 20 times my X, because I don't know. Right now it's starting at $1. I don't know that it's always going to be $1. Right now, this is in what we call vertex form, which we'll talk about later. Okay. We want to get this in standard form. What do I need to do? Coil. What is 35 times 380?
let me pull out my calculator real quick. Hold on.
Oh, so you with it.
I'm pretty sure that's what it is, yes? I just did it earlier and I can remember, that's why. What is, I don't remember this though, what is 35 times 20x? What's 35 times 20x? I don't know that one.
700.
700.
Okay, 700. 700x. What is negative x times 380? That's an easy one. And what is negative x times 20x? Negative 20x squared. So let me go ahead and reorganize that, yes, so that I do it the way I like. 700 and negative 380 is what?
What is it?
What's 700 minus 380?
No.
220.
320
That's what I
x
thought, but okay, yeah.
plus 13,300. Okay, now I am trying to find the maxima, the vertex. So what do I need to do?
The X thing.
Yeah,
X. X
equals
equals
negative b over
opposite
2a.
b over 2a. My b in this case will be negative 320. My a is negative 20.
Oh my
What
God.
is negative 320 divided by negative 40?
8.
Okay, now that is my x. Is $8 or is 8 my revenue? No, what's my revenue?
We have to plug that back
We
in.
have to plug that back in. So I'm going to plug this in so that it says R equals negative 20 times 8 squared plus 3,200, no, 320 times 8, right? Plus 13,300. What is 8 squared?
Oh my goodness.
64. 64. 64 times negative 20 is negative 1280 plus 320 times 8, which is 2,560 plus the 13,300. When I add all that together, you should get 14,580. So what they're saying is the maximum profit you can make, okay, per week is $14,580. If you lower it from $35, if you lower it $8 per racer.
That's extra.
So sometimes it's better for us to lower the price of things so that we can make more in the long run.
You're right. I'll save that for econ tomorrow.
Okay.
Because I'll probably need that because we're doing like